Hello students, welcome back to Algebra 2. Today we're going to talk about solving quadratic equations by using square roots. Now before we get into this, I just want to remind you of one thing going off to the side. If I have a very simple quadratic equation like this, x squared is equal to 9. The way that I get rid of the squared in an equation, the inverse operation is to take the square root like this. So the square and the square root cancel each other out, giving me x. However, the thing that you have to remember is the square root of 9 is 3, but it is also negative 3. Because 3 times 3 is 9, but negative 3 times negative 3 is also 9. So I would get this equation here. If I take the square root of 9, I would get x equals 3 or x equals negative 3. Since that's a very simple equation, I could say x equals 3 or negative 3. Or if you're feeling saucy, you could say x equals plus or minus 3. Let's go back to these ones. Okay, so if I want to solve this equation right here, 4x squared minus 31 equals 49 by using square roots, what I'm going to do here is add 31 to both sides. So I'll get 4x squared is equal to 80, and then I'll divide by 4, giving me x squared equals 20, and then I'll take the square root of both sides, and I will get x is equal to, now I have to find the square root of 20. And we want exact answers in this one, not decimal approximations. So that means I need to reduce that radical. So we remember from Algebra 1 that the square root of 20, we break this down and look for perfect squares. So this is 2 times 10, and 10 is 2 times 5. So the square root of 20 is 2 times 2 times 5. And there's my perfect square right there, 2 times 2. So 2 times 2 is a 2 on the outside with a 5 on the inside. So x equals 2 times the square root of 5, but it's positive or negative, so I'm just going to slap a plus or minus in front of it right there. Okay, 3x squared plus 9 equals 0, so I'm going to subtract 9, and I'm going to get 3x squared equals negative 9. I'm going to divide by 3, I'm going to get x squared equals negative 3. And then I take the square root of this on both sides. And if you type that into the calculator, the square root of negative 3, you're going to get an error because we don't know how to do the square roots of negative numbers yet. There is no number times itself that equals negative 3. And I hate saying that because I'm going to tell you, yes, there is next lesson. So for this lesson, if I try to take the square root of a negative number, the answer is no real solution. And it's very important that you put the word real in here, because starting next week, we'll start having complex solutions where we can answer that. We'll talk about that next week. Okay. So now this one is going to get a little bit more complicated. I'm gonna sharpen my pencil here. 2/5 x plus 3 squared equals 5. Now I want to get rid of the 2/5 first, and I do that by multiplying by 5 halves. I'm going to multiply both sides by 5 halves. So I'm going to get x plus 3 squared is equal to 25 halves. Now at this point, I'm going to go ahead and take the square root of both sides. 1 second real quick. Okay, so I'm going to get x plus 3 equals plus or minus the square root of 25 over 2. Now, before I move any further, there's an idea that is briefly discussed in Algebra 1 called rationalizing a denominator. So the rule is you are not allowed to have a fraction inside a square root. So here's how we do take care of this. I'm just going to make a little note here on rationalizing. So we have this fraction right here, 25 over 2, which is the same thing as the square root of 25 over the square root of 2. Now, square root of 25 is just 5, so I can simplify that. But now, what happens is I have this square root in the denominator of my fraction, and I don't want that. I want any square roots that I have to be in the numerator of the fraction. So what I'm going to do is, just like in elementary school, I can multiply anything times the denominator as long as I do the same thing to the numerator. So I want to multiply the square root of 2 times a number that is going to make it not a square root anymore. So what I'm going to do is I'm going to multiply it by the square root of 2. Logic being, the square root of 2 times the square root of 2 would be the square root of 4, which is 2. So I can do that same thing to the numerator. So that's going to give me 5 square root of 2 over the square root of 4, which turns into 5 times the square root of 2 over 2. Meanwhile, back at the ranch, x plus 3 is equal to plus or minus 5 times the square root of 2 over 2. This isn't done yet, so what I need to do here is I'll subtract 3 on both sides, and I will get x equals negative 3 plus 5 square root of 2 over 2. Now, since this radical is here, oh, sorry, I forgot the minus. Since the radical is here, these are not like terms, and so I can't move any further, so this would be the answer. Now, just for a moment, let's suppose that they were like terms. Let's say that we had 3 plus or minus something like 7. Excuse me. In that case, I would have to split it into 2 parts, one with a plus and one with a minus, and then I would get 2 separate answers, 10 or negative 4. Now, please remember that this is actually 2 answers. It's 3 plus 5 square root over 2, 3 plus 5 square root of 2 over 2, and negative 3 minus 5 square root of 2 over 2. But this is a way of condensing our answer.